So when we are talking about chemical equations, it is literally a description of a chemical reaction. And I like to abbreviate chemical reaction with that little R and all that. It's a lot easier than writing out reaction. Chemical equations are descriptions of chemical reactions. So chemical equations are always in this form. Before anything reacts, we have what are called reactants. This is what you put in the pot and see what happens. The arrow literally means produces or yields. The arrow means produces or yields. And then we end up, after we mix things, if there's some sort of chemical reaction, we end up with what are called products. So I can, if I decide to put some sodium and chlorine in a container and see what happens, the sodium will react with the chlorine to produce or yield, that's what the arrow means, a product called sodium chloride. Question, reactants are before, products are after. Before and after what?
The reaction.
The reaction. Good. So that's an example of a chemical reaction. Sodium and chlorine react to produce sodium chloride. So sodium reacts with chlorine to produce sodium chloride. In this case, I have two reactants and one product. So if we abbreviate, we end up with something like this. But does anybody see anything wrong with it? So if you were to put some sodium and chlorine in a container, the sodium atoms are just a bunch of NAs. The chlorine atoms, part of Brinkelhoff, are diatomic molecules. They will come in the form of Cl2, just like that. However, notice in the reactants, we have one sodium atom and two chlorine atoms. But what's in the product? One of each. Yeah. What does this violate? The law of conservation of mass. So this is what is called an unbalanced equation. So this unit is all about balancing those equations. In order to balance it, it means you have to have the same number of atoms before the reaction as after the reaction, and that satisfies the law of conservation of mass. There are quite a few rules to it, and those are the rules I'm going to teach you now, and then we'll do a bunch of practice ones. Say write the correct formulas. Here, this first compound is sodium atom, and it's just Na. This is chlorine, but because it's a Brinkelhoff, you got to make sure it's Cl2. Sodium chloride, like we did last semester, sodium's got a +1, chlorine -1, write the formula NaCl. So you've got to double check all of those to make sure you have the correct formulas. When you put in coefficients, the coefficients balance it out. Coefficients go in front of the compound. This 2 applies to all of this. But take a look at this 2. This 2 applies to sodium. It does not go for the rest of it. So what you got to do is I like to count. I do a little thing right here. We have the reactants.
Yeah, that's the easier way. It's cool.
We have the products. We have sodium and chlorine. So I'm just going to keep a tally. How many sodiums in the reactant? 2. How many in the product? 2. How many chlorine in the reactant? 2. How many chlorine in the product? 2. So everything is balanced. Everything is I don't have equal numbers up there. I have equal number of atoms in the product and the reactant. Notice what I don't have right here.
A 1.
Yeah, we don't actually write 1. That's 5 days ISS. Okay, so make sure that you don't write a 1. The 1 is understood. So once you do your coefficients, make sure that you have the right number of atoms on the reactant side, the product side, everything works out, and then it's balanced. Notice that you can add coefficients only. Do not do subscripts at all, okay?